Now that we understand a bit more about how decomposition works and why it's useful, let's look at some programming problems where it might be useful for us to use functions. What we want to do is draw a sequence of 5 faces where each face is the same and is evenly spaced along the canvas. There are several approaches we could use to solve this problem. We could write the code to draw each face individually, which would look like this. Or we could improve on this by using a for loop like this. Then we'd only have to write code to draw the face once, but this is still less than ideal as we need to keep track of where we are drawing the current face. Neither of these approaches is really that versatile. If we decompose this problem, we immediately see how we can improve the process. Looking at a flowchart of the program, can you see how to improve it? We draw the same face 5 times. The only thing that changes is the location at which we start drawing, and we know how we can use variables to change this for each face. This seems like a good place to use a function. If we write a function to draw the face and use the function's arguments to tell processing where to start drawing it, we can then call this as many times as we like. 5 faces? Easy. 100 faces? No problem. So let's start turning the face part of our problem into a useful function. We're going to call it drawFace. Does it need to pass any values back? No, which means we can use the void return type. Finally, we need the function arguments. Where we start drawing the face is up to us, but for this example we're going to use 2 integer variables x and y to represent the top left corner of the face, and these will be our arguments. Now we have our function, we can take the lines of code that were inside the for loop and use them to build our function. We're not quite done because we need to make all of the shape positions relative to the x and y arguments. Once we do this, we see the following on our canvas. We often test a function early on by executing once to see what happens. That way, if it's wrong, we can correct it easily and then try calling it multiple times. Excellent! We now have a function correctly drawing one face, and now we can use our for loop to make multiple calls to the function. This will place faces evenly along the canvas width, just as we wanted. Now that we've seen how we can decompose a simple problem, let's look at something with a few more parts. The program we want draws faces on the canvas, but now it can draw a cat face, a dog face, or a human face. How would we decompose this into parts? Well, one obvious component is drawing each type of face. Each face could be an individual function. But rather than calling each drawFace function, it might be better if we could pass the type of face we want to draw to another more complex function, along with the coordinates, and this forms another building block in our program. The code for drawing each of the different faces looks like this. We can see that all of these functions return no values using the return type void as they just draw to the canvas. We've given them sensible function names so we know what each one does, as well as providing the arguments x and y for where we want to draw it. In addition to taking the coordinates, we need to identify which type of face we want to draw, and this is passed as a string to the function, which then uses conditional statements to decide what to draw. And that's it. We can draw animals to the screen by calling the drawFace function and passing it the x and y coordinate for where to draw, and a string representing the face to draw. If we wanted to draw a cat face at position 100, 100, we would write drawFace 100, 100 cat. If we wanted to also draw a dog face, we only need to add one line, drawFace 300, 300 dog, and now we have a dog. By using functions and decomposition of the initial problem, we've been able to reuse significant amounts of code, which saves a lot of time. When you're thinking about using functions, think about the decomposition of the program. By identifying the areas that are either the biggest or the most widely reused and defining functions to implement them, we can build programs more quickly and have fewer problems as we do. I'll see you soon.